It is possible to escape a black hole, which is what actually defines it, and nothing appears more hopeless than trying to do so. The ultimate no man's land is the singularity at the center of a black hole, where all concepts of time and space are entirely lost, and matter is compressed to an infinitely small point. Join us in our discussion about the concept of black holes and how they are formed.
Audio Jungle.
Inside a black hole. Because all of the mass in a black hole is concentrated in one place, the gravitational field around it is incredibly powerful. Usually, stars 10 to 15 times larger than the Sun are used to create black holes. Because even light cannot escape a black hole's gravitational pull, the object is invisible. A black hole is made from two parts, the event horizon and the singularity. An event horizon is a section of the black hole. This is the black hole's surface. The gravity at the event horizon is infinitely powerful. At the speed of light, an object at the event horizon will be drawn into the black hole. Short of traveling faster than light, a physical impossibility, nothing can escape from behind the event horizon. It is irretrievably lodged inside the black hole. The term singularity refers to the other component of a black hole. The center of the entire black hole is located here. It is thought that this region of the black hole has infinitely powerful gravity but no volume. Resistance is encountered as matter squeezes downward under the powerful gravitational pull of a collapsing star. The Planck length, or roughly 1.68 times 1,035 meters, is the minimum that matter can travel in space-time due to its discrete nature. Everything that has ever entered the black hole is condensed into a ball hardly larger than this. Though perfectly minuscule, it is not eternally small. Characteristics of black holes. Recall our earlier discussion of matter squishing? It's possible that matter isn't compressed to an impossibly small point deep inside a black hole. Instead, there might be the smallest conceivable arrangement of matter, the lowest possible volume pocket. All the matter of a black hole is concentrated in one spot at its center. Our conception of motionless, non-rotating, uncharged, fairly dull black holes gives rise to the concept of a single point of infinite density. The characteristics of real black holes are significantly more compelling, especially when they spin. The singularity is stretched into a ring by the spin of a revolving black hole. The only mass we have is from Einstein's theory of general relativity, and it predicts that after passing through the ring singularity, you will enter a wormhole and emerge from it through a white hole, which is the antithesis of a black hole, where nothing enters and matter escapes at the speed of light into a brand new and fascinating region of the universe. One difficulty is that the interiors of rotating black holes are extremely unstable, and this is in accordance with the exact same mathematics that supports the prediction of the stuff involving traveling to new universes. Rotating black holes are problematic because, well, they revolve. Stretched into a ring, the singularity rotates at such a tremendous rate that it exerts extraordinary centrifugal force. Furthermore, in general relativity, these are centrifugal forces that are powerful enough to push instead of pull like anti-gravity. As a result, the inner horizon, a boundary inside the black hole, is formed. Radiation is falling inward towards the singularity outside of this area due to the strong gravitational force. The inner horizon serves as a turning point when radiation is pushed by the anti-gravity close to the ring singularity. The entire past history of the cosmos would be blasted into your face quicker than the blink of an eye if you were to come into contact with the inner horizon. Black hole formations. When a large star is smashed by its own gravitational pull, black holes are created, and only when a star runs out of nuclear fuel is it capable of being crushed by its own gravitational pull. All stars burn fuels that produce an outward push, which when combined with gravity's pull inward, results in the development of a star. Because a star loses its ability to burn fuel, it falls in on itself due to gravity after it stops burning fuel. Early in the universe, right after the Big Bang, it is considered that primordial black holes were first created. A big star's core collapsing in on itself creates a stellar black hole. A supernova, or exploding star, which hurls a portion of the star into space, is also brought on by this collapse. Supermassive black holes may have originated along with the galaxy in which they are found, according to scientists. The mass and size of the galaxy that contains the supermassive black hole affects its size, in order for time-space to collapse in on itself in a violent feedback loop of squeezing and stretching that feeds more squeezing and stretching. Enough matter needs to be compressed within a sufficiently small area. This is how black holes are created. Does a black hole live forever? It has long been believed that black holes cannot be destroyed, because nothing can escape their gravitational pull. But as of late, it has become clear that black holes actually evaporate, gently releasing their energy into space. This was demonstrated in 1974 by well-known physicist and author Stephen Hawking, who examined the region near a black hole horizon using the principles of quantum physics. The tiniest scales of matter's behavior are described by quantum theory. It asserts that on subatomic scales, light and small particles are continuously created and destroyed. In fact, there is extremely little probability that any of the light that is produced will escape before it is destroyed. The event horizon seems to an observer as though it is glowing. The mass of the black hole is gradually reduced until it vanishes due to the energy taken away by the glow. Black hole evaporation. The emergence of an inner horizon plants the seeds for the black hole's eventual demise. Information is lost in black holes. Stephen Hawking, an English theoretical physicist, cosmologist, and novelist, demonstrated how a black hole might dissipate over time, turning into a featureless cloud of radiation, both itself and anything it absorbs. In the process, it appears that knowledge about what entered the black hole is lost, breaking a fundamental tenet of physics. The black hole looks to be burning away from the outside. However, it is happening so slowly that it is impossible to see in real life. When you burn a book, the words on its pages leave an impression on the pattern of the light that comes out and the ash that remains. Thus, at least in theory, this information is kept. The data about what falls into an evaporating black hole would be encoded into the emerging Hawking radiation if it were a typical system like the burning book. What actually occurs within a black hole? The frightening element is that we might never know what will take place in this singularity, even though we know that something must eventually replace it. And that's how far we can go on this video. Thanks for watching, and don't forget to like and subscribe.